Hello everyone, we are Group 4, and today, we will present the analysis of height and weight data we collected from a sample of students. This topic inherently involves probability and randomness because the height and weight of each student are considered random variables. Following a specific probability distribution within the population, we can only determine their exact value once the measurement are recorded, making the observed data a realization of this random process.
For probability distribution, we have a table of the data we collected from students. For table number 1, we have their height and weight. For table number 2, we have their frequency for each height and weight combined. The only combinations that appear more than once are 5'6" and 58 kg with a frequency of 2, and 5'9", 90 kg with a frequency of 2. Therefore,
we begin with the descriptive statistics for a sample of 30 scores. The average performance or the mean is 58.55. Our standard deviation is 15.79. This value indicates that a typical score deviates from the average by nearly 16 points, showing a significant spread or variability in our data. Next, we analyze the shape of the distribution. By comparing the mean to the median, we determined that the data is not approximately normal. Instead, it is positively skewed. Moving to the normal curve application, we use the principles of the normal distribution to interpret where scores fall. We first convert raw scores into z-scores to find their position on a standardized scale. A score of 50 is 0.54 standard deviations below the mean, which gives us a z-score of minus 0.54. Using the z-table, we find that 29.46% of scores are expected to be 50 or lower. Meanwhile, a score of 44 is 0.92, standard deviation below the mean. With a z-score of minus 0.92, this means approximately 17.88% of all scores are expected to be 44 or lower. Finally, we solve for the raw score that separates the top 40% of performers. The 68th percentile boundary corresponds to a critical z-score of 0.25. Converting that to z-score back to a raw score gives us a 62.50. Therefore, a score of approximately 62.5 separates the top 40% of the distribution from the bottom 60%.
Now, after all we have discussed, we came to a conclusion that our lesson that we've shown today is very valuable to our daily lives, not only in the mathematical, academically sense, but also personal. We can calculate our own beliefs, but what we believe in and our own data, whatever we try.